Hi, welcome back to my channel, Sino Informatica. Today topic is context-free grammars. What is meant by context-free grammar? A grammar is a set of rules for putting strings together and so corresponding to a language. So we're saying that the grammar contains the set of rules all are putting together to frame the string, which corresponds to the language. Grammars. A grammar consists of a set of variables, is also known as non-terminals, one of which is designated that start variable. It is customary to use uppercase letters for variables, that is capital letters A, B to up to Z. A set of terminals form the alphabet, that is input symbol, whereas we are going to say in that in the finite automata we're considering the alphabet as sigma. Here we can consider terminal as a sigma or T. List of productions, also known as rules. To generate a string, we need set of productions. In the grammar, we have the variable. Variable derives a rules. This is called a productions. Okay. Here we consider one example: 0 power n, 1 power n. Here a grammar is written as with the productions or rules. The starting symbol is S. S tends to 0. Here we have the 0, S, 1. Where the given example is 0 power n and 1 power n. So here the production, the given example is starting with 0. So the production is going to start with a 0 and name with 1. In the given example, ending with 1. Based on that, I considered S tends to 0, S1. So in the place of S, I can n number of times I can substitute this production in S, so that I can get the 0 power n S 1 power n after substituting of n times of S tends to 0 S1. And finally, I am going to substitute in the S tends to epsilon to satisfy the considered example, that is 0 power n, 1 power n. Clear? To get the 0 power n, 1 power n, I am going to substitute in the S production or S rule n times, so that I am going to get the 0 power n, so that I am going to get the 0 power n S 1 power n. When I am going to get means substituting of S tends to S tends to n times. I am going to substitute in that production n times, so that I am going to get the 0 power n S 1 power n. At the place of S, I am going to substitute in this one at last, that is epsilon, so that finally I am going to get in that 0 power n 1 power n. Clear? So S is the only variable. The terminals are 0 and 1. There are the two productions. These are the two productions, or we can say two rules. Yes, rules. Clear? Next, coming to the using a grammar, a production allows one to take a string containing a variable and replacing the variable with the RHS of the production. Clear? Why we are going to substitute means to generate a string W of terminals is generated by a grammar. If starting with the start variable, one can apply productions and end up with W. The sequence of string so obtained is derivation of W. Whatever we are going to get in the string is called the derivation of word. W indicates the word. Clear? From where it is going to generate means by substituting the productions or rules. Whatever occurring from the terminal to variable to with the right hand side of the production. Right side of the production is going to be replacing with the that start symbol or variable. We focus on a special version of grammar called context free grammar. A grammar is a context free. If a grammar generates a language, then it is called a context free language. Generates itself or generate it. The continuation of the previous example, S tends to 0, S1, S tends to epsilon. These are the two productions of two rules we are having. The string we are going to generating 0011 is the language generated. According to the previous definition of the language, the string is going to be generating 0011 instead of 0 power n, 1 power n. I am going to consider 0 power 2 and 1 power 2. The derivation is like this. First I am going to substituting considering the S tends to 0 S1. That is the first production. After that to occurrence of 0 1, I am going to substituting again first production so that 0 0 S 1 1. To get 0 0 1 1, I am going to substitute in the second production so that I am going to get in the 0 0 epsilon 1 1. So there is a no value for the epsilon. So finally I am going to get 0 0 1 1. For compactness, we write S tends to 0 S1 slash epsilon. That is, two productions is going to shown in the single line. Where the vertical bar means R. Here the vertical bar represents that R. This is the vertical bar. It represents the R. That is S tends to 0 S1 or S tends to epsilon. Clear how you are going to read the production rules? By applying the bar, vertical bar means R. Next example is palindrome. The palindrome is what? From left to right, right to left, it has to be the same value, same string or string number. So let us consider, let P be a language of palindrome. Let P be a language of palindrome with alphabet A comma B. That is sigma A comma B or terminal A comma B. One can determine a context free grammar for P, for the production P, by finding a recursive decompositions. If we peel first and last symbols from a palindrome, what remains is a palindrome. And if we wrap a palindrome with the same symbol front and back, then it is still a palindrome. Let us consider context free grammar is P tends to APA slash, that is, or B P B or epsilon. This rules or productions going to generate in the palindrome. That is, it can be generate the string called AA or BB or AB BA or BA AB. At first step, consider P tends to APA and substituting here epsilon. Then I'm going to get in the first string AA. Next I'm going to consider this second production and substituting at the place of P, substituting with the epsilon, I'm going to get the BB. Or I'm going to be considering the first production P tends to A, small a, capital P, small a, and substituting the second production at the place of P, that is B, P, B at the place of this one, so that I'm going to get A, B, B, A. That is the second string. If I consider second production as the first one, that is I'm going to consider this production first. So B at the place of P, I'm going to substituting at the place of P, I'm going to substituting at the place of P, I'm going to substituting this string, this production. Then I'm going to get B, A, B. Clear? By substituting the multiple times, I may get the BA, BA, AB, AB. Like that, the string will be increased. Actually, this generates only those of even length. You can see here the length is 2, here length is 2, here the length is 4, here length is 4. If I substituting here P again at the B, then the length will be 6. If I substitute again, I will get the length of 8. Clear? So it gives the only the length of even length of string of palindromes. Next, the formal definition of context-free grammar. One can provide a formal definition of context-free grammar. It is a 4-tuple or 4-component V, T, S and P, where V is a finite set of variables, that is a uppercase letters. T or sigma is a finite alphabet of terminals. Clear? Sigma or T, we can define it is a alphabet of terminals, finite set of alphabets of terminals. S is a start variable, that is starting production. P is a finite set of productions. Each production has the form V tends to V union sigma whole star, or we can say that V tends to V union T whole star. Here I can write, instead of sigma, I can write the T also. Why means I'm going to defining that alphabet terminal with T. So I'm going to represent the T here. Clear? This is the formal definition of context-free grammar. Now we'll see the next example. Even number of zeros means it is a binary number. So a context-free grammar for all the binary strings with an even number of zeros. Finds the decomposition. If the first symbol is 1, then an even number of zeros remains. If the first symbol is 0, then go to the next 0. After that, again an even number of 0 remains. This yields S tends to 1s. The first production is writing that to satisfy the condition of even number of zeros, S tends to 1s. So that at the place of S, I can substitute a 0, A, 0, S. Or I can substitute a epsilon. If I substitute this, I am going to get 1, 0, A 0 S. At the place of A, I am going to substituting epsilon or 1A. I am having the two productions. I am having the two productions, so that I can substitute either 1A or epsilon. So if I substitute epsilon here means I am going to get here 1 0 epsilon 0 S. Now at the place of S, I can substitute 1S. If I substitute 1S means I am going to get 1 0 0 1 S. At the place of S, I am going to substitute in the epsilon. Now I got the string is 1 0 0 1. So here you can observe that I got the even number of zeros here. There are two zeros and two ones. Clear? If I substitute instead of epsilon, I can substitute again 0A 0S. Like that I can substitute n number of times, even though I am going to get the even number of zeros only. Clear? Next, generating a production with the regular expression. Here we have the consider the a context free grammar for the regular language corresponding to the regular expression, that is 0 0 power star 1 1 star. Here that gives the 0 with n number of zeros, 1 followed with 1 number of ones. So the language is concatenation of two languages, that is all zeros with all string of zeros with all string of ones. I can consider this as two languages. This is L1, this is L2. The first language is accepting the all strings of zeros. Second language is going to accepting the all strings of ones. Clear? For that, I am going to consider in the production rule as S tends to CD. The C indicates the first language, D indicates for the second language. Now I am going to writing for the first language. C tends to, the first language is starting with 0. So 0C slash 0. So I can substitute 0C n number of times, so that it can going to be satisfying. At last I can substitute the single 0. In the same way for D, 1D or single 1. So that by using these productions I can generate the 0 star 0 0 star 1 1 star. Let us see how to derive that string. Instead of 0 power star, I am going to considering that 0 0 square 1 1 square. Right? First production is this one, S tends to CD. Right? I am going to substitute in that S tends to, in the at the place of C I am going to substituting the 0 C D. Right? to occur the three zeros, again I'm going to substituting the C tends to 0C, so that it will becomes 0, not a 0, it's not a D, 0, C, again I'm going to substituting the C here, so 0, 0, C, D. So in the at the place of C, I am going to substituting third production. So 0, 0, 0, D. At the place of D, next step I am going to substitute in the 1D. So 0, 0, 0, 1, D. Again second time again I am going to substitute in the 1D to occur the second time of second occurrence of 1, 1, 1, D. Now I am going to substitute in the equation 4, that is D tends to 1, so that 0, 0, 0, 1, 1, 1. So this is the derived string from the regular expression, that is 0, 0, that is 0, 0 star, 1, 1 star, that is 3 zeros and 3 ones. So finally I got the 3 zeros and 3 ones. From the regular expression we can generate the productions also. A silly language context free grammar, that is for the grammarly, for the writing the sentence we are going to be constructing it in the form of context free grammar. The context free grammar sentence as a composite of noun and verb phrases. So S tends to noun phrase and verb phrase. Noun phrase tends to the noun. Verb phrase tends to verb and noun phrase. V tends to sings or eats. N tends to noun. So noun tends to cat, song, canary. These are the productions. This generates the, first I'm going to generate in the S tends to NP VP. So NP is deriving the noun. So the, in the place of noun I'm going to substitute in the N tends to canary, the canary. Next we have the VP. VP tends to V. At the place of V I'm going to substitute in the sings. Next I am having the NP. Again the, at the place of noun I'm going to substitute in the song. The canary sings the song, but also the song eats the cat. I can substitute that, I can generate that string also. This context free grammar generates all the legal sentences, not just meaningful ones. So it can give the any legal sentences, not only the meaningful one. Clear? Like this, we can generate the productions for palindrome, for verification of numbers, for any silly languages, for anything we can construct the or generate the productions in a context free grammar. I hope that you understand the concept of context free grammar, how to define the formal context free grammar, how to write the productions by using the variables and non-terminals. Thank you.